So let's derive a formula for the surface area of a sphere of radius r. So again, we'll use spherical coordinates. X equals r cos theta sine phi, except I'm spherical coordinates, except I'm using r for the radius instead of rho. And also now r is a constant. Y is r sine theta sine phi, and z is r cos phi. And again, I'll call this s of phi theta to avoid confusing it with the radius r. Okay, so s sub theta cross, or s sub phi cross s sub theta is, okay, so with phi, we're going to get r cos theta cos phi r sine theta cos phi, and then negative r sine phi. And with theta, we'll get negative r sine theta sine phi, r cos theta sine phi, and then 0. Put ijk at the top. So now we evaluate this determinant. We can pull out an r sine phi from the bottom row. So this is r sine phi. We can also pull out an r from the second row. So it's r squared sine phi. And now let's see. So with I will have cos theta sine phi I. Then j, so that'll be like this, and then this cancels out that negative, so plus sine theta sine phi j, and with k we'll have cos squared theta sine squared theta, so plus cos phi k. What you might notice is same as r squared sine phi xi plus yj plus zk. So you maybe also could have just noticed that the normal direction on a sphere is parallel to like the vector from the origin to that point on the sphere. I'll mention another thing. Another trick you could have done is taken r equals 1 throughout this calculation, so only done it for the unit sphere, and then just said the area should scale by a factor of r squared. So you could sort of have predicted that, just put this r squared factor in at the end. Okay, but so our formula is, so it's integral over r s phi cross s. I should have said this is, so since this we know has magnitude equal to 1, since it's this is r sine theta, and then because the r comes in here, so this has magnitude equal to r. So the magnitude of s phi cross s theta is r squared sine phi. Sorry about that. Okay, so s theta d phi d theta. So this is integral 0 to 2 pi integral 0 to pi r squared sine phi d theta. So we can pull out the r squared, and again, the theta is just going to give us 2 pi. So this is 2 pi r squared integral 0 to pi sine phi d phi. And so that's 4 pi r squared is the surface area.